All right, I'm going to break the review down into a couple videos just to kind of help you working through it. The key has already been posted, so you can check with that. Let's just kind of walk through a few of these problems if you need help. Again, read through those instructions. Remember, this is to help you study for the exam. So let's kind of see what we remember and how we're doing with these. To start out with, we're given a function f of x is equal to 2, x minus 3 squared minus 2, and asked to identify these key features and then graph the function. Now recognize this is raised to the second power, so this one right here is quadratic, so we know that it is going to create a parabolic shape. So again, this one is in vertex form. So vertex forms means that this is our h value, this is our k value. So when we identify our vertex, we just pull that out as 3, negative 2. Our x-intercepts I'm going to get from the graph. The increasing interval, remember it increases on one side and decreases on the other. This has a positive 2 out front, so this guy is going to be opening up. And it looks like if that was our axis of symmetry, remember that goes through the vertex, so like 3. It's going to decrease on the left, and then it's going to increase on the right. So I'm going to say where x is greater than 3, it's going to increase. Or again, if you like to write 3 to infinity, that just means on the right side of the graph. And where x is less than 3, we are going to decrease. So this would be negative infinity to 3. Our domain always remains the same for these quadratic functions. All real numbers work, negative infinity to infinity. And then again, our graph is opening up, so that means it's going up to infinity, and we start at our y value of the vertex for our range. Or again, if you like to write it in inequality notation, you can use y is greater than or equal to negative 2. Then we graph the function. So again, we start with the vertex up here. So our vertex is at 3, negative 2. So I go to the right 3, I go down 2, and I go ahead and plot that vertex. Now, remember this out front is a 2, so this is being stretched by 2. So generally our function for a quadratic goes up by perfect squares. So we would go up 1, right? Then it goes up 4 here. I guess that was counted absolutely incorrectly. 1 here, and then 2 units away we're up 4. Same thing on the other side, so here and here. But this one has been stretched by 2, so we are going to go over 1 and up 2. So we're going to hit there, and we're going to hit there. It would then go over 2 and up 8. 1, 2, 3, 4, 5, 6, 7. That's going to go right off the graph. I'm going to draw it just to help me kind of create my shape correctly. But again, we could go by 2s or something to make it fit more. So here's my, trying to draw a little parabola there. He's very tall and skinny. Excellent. So then we can identify those x-intercepts up here. Again, it looks like it's crossing at 2, 0, and 4, 0. We'll talk about how to solve that algebraically next chapter. Okay, number 2 is a multiple choice question. Which of the following is not a quadratic equation? Remember, quadratic equations have a degree of 2, so if we look at this one's definitely quadratic. Part B, this one has a variable in the exponent, so that actually means that guy is exponential. So this one is not quadratic, definitely that one. So again, looking at that, part C, definitely quadratic here. This is an intercept form. The x and the x, and then down here this is vertex form. So there's our 3 forms of quadratic: standard, intercept, vertex. Those are all quadratics. Number 3, given the function y is equal to 4x squared plus 32x plus 19, we're asked to first write it in vertex form. Again, remember vertex form is where we pull the a value out front, and we're left with, I should put minus in here, that's the normal one, a k value on the outside. So we are going to start by writing y is equal to 4x squared plus 32x, and we move the 19 out of the way. So it's going to relate to the k value. We then start to factor those first 2 pieces. We need to pull the a value out front, which means we leave x squared plus 8x on the inside, and we still have a positive 19 over there. Now that we've got that out, we are going to add in our perfect value, and we always do that by taking half of that middle term and squaring it. That gives us 16, so I'm going to add 16 here. Again, remember there's a 4 out front, So what you really added into that equation was 4 times 16, which is 64. So on the outside, to keep it balanced, you want to subtract 64. Then we go ahead and factor. So we're going to have y is equal to, again, that 4 just stays out front. We factor the trinomial, and then on the end there, we combine those like terms to get negative 45. So if we subtract the trinomial, we get x and x. Everything is positive. Half of 8, right, would be 4 and 4. That multiplies to 16. So our final vertex form, we put the x plus 4 together, and we could get subtract 45. So this one is now in vertex form, and then it asks us to state whether it has a max or a min. We look out front to see if it's going to open up or down. So that's a positive 4, which means this parabola is opening up. So this bottom vertex would be the minimum value of the graph. And that minimum value, if the vertex coming from that equation we just found is at negative 4, negative 45, the lowest the graph ever goes is that negative 45. Last one on page 1, which of the following has an increasing interval of negative 1 to infinity? So if we're looking at that, again, we want to know if it's opening up or down. And if you look at this part A, it has a negative out front, so this one's opening down. This one's opening up, right? We can kind of tell this one's opening down, this one's opening up. So if I'm going to have an increasing interval of negative 1 to infinity, that means that x is always greater than negative 1, right? So that means that it's increasing on the right-hand side of the graph. So if that's the case, that means this must be a parabola that's opening up. So we know that it's not A or C. And then we want it to be greater than negative 1. So if we look at the axis of symmetry for each of these, that axis of symmetry is negative 1, where this one is a positive 1. So we know it's not D, so we're looking at B. Again, you could always graph this where it's multiple choice and then just determine which one is increasing on that interval. All right, we're going to do a couple more on this video. Number 5, graph both the function f of x is negative x squared plus 4 and g of x on the grid. Oh, that says gid. Compare the two graphs. So again, remember that the 4 right here would mean that it moved up 4. The negative would mean that it reflected over. It hasn't been stretched or shrunk at all, so I can graph this one pretty simply. I'm just going to go up 1, 2, 3, 4, and I'm going to go down by perfect squares. So if I'm 1 unit away from the vertex in either direction, 1 squared is 1. If I'm 2 units away, 2 squared is 4, so I'm 4 units up from the vertex. Or again, you can know that it's counting by odd numbers, right? So it's going to be looking something like this. And if all else fails, again, you're always welcome to use your calculator to plot some points for that. So this one is f of x. We could then graph g of x. Let me use a different color. Maybe let's go with some purple. G of x is just x squared, so that's the parent function. So it sits at the origin, it hasn't shifted anywhere, and it has the behavior of going up by perfect squares as that parent function. So we can draw him here as the U shape going up. Now it says compare the two functions. So if this is g of x and it's the parent function, and then f of x, it looks like has been reflected. So we could just say something about f of x, right, has been reflected over the x-axis and shifted up 4. So notice that went up 4. Where g of x has no transformations applied, or you could say is still sitting at the origin. Anything to kind of compare those two using that correct vocabulary. Okay, let's do 2 more on this one. So number 6 says the front of a storage bunker can be modeled by this function given. So we're given a function here. It looks like it's in intercept form where x and y are measured in inches. The x-axis represents the ground. Determine the width of the bunker. So first let's look at the picture. If I'm determining the width of the bunker, there's one side of it, there's the other side. It looks like I just want to find this total distance here at the bottom of the bunker. And I can tell, right, that this is going over, here's 60, maybe that's 70. It looks like it's crossing somewhere around there. A little bit hard to tell. That's where our equation comes in. So using that equation they just gave you, if you were solving or finding the x-intercepts from the equation, this tells you that it's going to be 72 and negative 72. So it must be crossing. If you look at your graph, that must be negative 72, and this is positive 72. So I wrote 70. Thinking about distance, right? This distance from the origin out here is 72 inches. This distance here on the left side is also 72 inches. So even though on the graph it's in the negative direction, it's still distance and length for this tunnel. So if we do 72, right, plus 72, we end up with 144 inches. So that's just utilizing our intercept equation along with a diagram. Number 7, determine the vertex of the function and state the zeros of the function. So remember the vertex of the function, we either find from using our vertex form, or we're given a function in standard form. So remember standard form, this guy has, I'm going to go for a lighter color, has an a value here and a b value and a c value instead of the h and the k. So to find the vertex, we need to do the negative b over 2a and then plug that in to find the y value. So if my b value, and I'm just going to write these off to the side, a looks like it's from that equation it's negative 2 and b is 6, then when I find my vertex, I'm going to have negative 6 over 2 times the a value, which is negative 2. So I'm writing it in the vertex just so that you can see that's what essentially we're finding. So that would be negative 6 over negative 4, right, as my vertex, and I'd probably simplify that. So this is really going to be 3/2, or in other words, 1.5. Okay. Now to find the y value, again, this would be my vertex right here, right? I'll label that vertex. But I need to find the y value. So we take the original function that we're given and we plug in that 3/2 that we found. So if that's the x value and we want to find its y value, we just put that 3/2 in there. And if you go ahead and calculate that, that's the same thing as, and you can do this in your calculator, but 9/4 plus 18 over 2, which is 9 plus 8. So we end up with negative 9/2 plus 17. Looks like we're going to get 12.5. So 12.5 here, or if you want to leave it as a fraction, you can. It's kind of weird. 1 fraction, 1 decimal. Okay, the second part asks us to find the zeros of the function. Remember, zeros of a function, if I draw a little x and y axis, really, when they say zeros, they're talking solutions. Solutions are the same thing as the x-intercepts. So x-intercepts occur when y is 0, so essentially we're just letting this equal 0, and then we have been practicing factoring to solve. So you would just go ahead and factor this. So take out a greatest common factor, x squared minus 3x minus 4. When we pull out a negative 2, we then continue breaking that down. We get x and x. We know that they're going to be different signs because of the negative 4. So we know that we're going to have a negative 4 times 1 would give us that middle term. So if I'm solving here, I get x equals negative 1 and x equals 4. Now you can write these as x equals. You could write them as x-intercepts, whatever you'd like to in relation to that. All right, that is the end of video 1. The next one I will go through some of the quadratic applications.